Hello everyone, I welcome all of you in the next online class of the heat and mass transfer. So today is the lecture 2, okay? Second lecture of this heat and mass transfer. So before I start this class, I'd like to revise the concept or the previous lessons which we discussed already in our previous classes. So in our previous classes, we had a discussion on heat and temperature. What is temperature? Temperature is nothing but the property of the body which indicates the heat will flow from which direction to which direction. Okay, so this is the property or thermal state of the body which identifies that heat flows from which direction to which direction. And what is heat? Heat is nothing but the amount of energy that transfer from one direction to another direction because of the temperature difference. So if there is high temperature and there is low temperature, so from high temperature to low temperature, heat flow occurs through body. Now depending on the body, there is different modes of heat transfer. So these are conduction, convection and radiation. So what is conduction? If the medium of the body is solid, then the mode of heat transfer is conduction. This one we already discussed. And if the medium of the body is liquid or gas, then this is called as convection mode of heat transfer. And if the medium of the medium of the body is gas, no medium is there, then it is called as radiation mode of heat transfer. So in conduction mode of heat transfer, we have seen that the solid molecules of the body are very closely packed and the molecules of the body solid is very close to each other. So if there is any temperature difference, so because of the temperature disturbance, the solid matter, molecules of the solid will start to vibrate. So because of this vibration, the next molecule also will start to vibrate. So like this, they vibrate and they collect the energy from one place to another place, and this mode of heat transfer is conduction. Now in conduction, we have seen one formula, that Fourier's law of heat conduction. There we see the formula Q equals to minus K into A into dt by dx, where this Q equals to heat transfer rate, K is called as thermal conductivity, A is called as cross-sectional area, and dt by dx is called as temperature gradient. So now going to the next class, for proceeding to the next class. So today we'll be starting with convection. So in convection, now the medium of this body is now liquid or gas. So remember the example. In that particular example what I gave, you have one hot rod and you have the hand. Now this hot rod and the hand both are not touched or both are not in contact. There is gap between hand and hot rod, and this gap is nothing but the air or ambient air. So now because of the high temperature of hot rod and because of the low temperature of hand, the heat flows from hot rod to hand. But this case, the medium is not solid because this is not directly contact. There is gap. So now the medium is air. So this is liquid or gas medium. Yes, this is gaseous medium. So in this gaseous medium, we told you that if the medium is liquid or gas, then the mode of heat transfer is convection. So in this convection mode of heat transfer occurs. Now I'll give you one example, one fine example. Okay, so you have one place here and you have another one place here. So now you stay here and you have one object. You have one object at this place and you want to move this object or move the stone, anything, move any object from this place to this place. So how do you move? So you as first you stand here at this place, your friend stay. Your friend stays here. So in this case, you take the object and you throw the object to your friends. So you throw the object from this place to this place and your friend catch the object. Okay. So in this case, you see the object moves from here to there by the medium of liquid. So that's why this is convection mode. Okay. This is convection mode. And you and your friend, they both are the molecules of the body. That may be liquid or that may be gaseous. And the object which is being transferred from here to there, that object is nothing but the energy or heat. So you see, fluid or means liquid or gas comes in contact with solid through direct contact and temperature difference exists between them. It occurs under combined action of conduction and mixing. Fluid comes in contact with solid, that means the hot. Heat flows by conduction from hot surface to adjacent stagnant layer of fluid. Internal energy increases, temperature decreases, density decreases. Lighter as compared to surrounding fluid particles, lighter moves up to a region of low temperature within fluid, and then they mix and exchange the part of energy with colder fluid particles. Cold moves down, it continues till equilibrium reaches. So here you see the convection mode. In this convection mode, you have one bucket. Inside the bucket you have the fluid, and the fluid has been heated from the bottom portion. So at the bottom of the bucket you have the hot fluid, at the top of the bucket you have the cold fluid. Now because of this temperature difference from hot fluid to cold fluid, there will be flow of energy. So as the fluid is heated at the bottom, now how it is heated? It is heated in the mode of conduction. How? Because you see the bucket, there is the thickness of the bucket, or there is a wall of bucket. So first heat will flow through the wall of the bucket to the fluid. So that's why the medium is bucket or medium is solid. So that's why the conduction mode occurs first. Next from wall to the fluid, from wall to fluid, the mode is convection. Why? Because from wall to fluid, you see there is the liquid is the medium. Liquid is the medium, so that's why this is convection mode. Now in convection mode, the hot fluid is at bottom, and top fluid, cold fluid is at top. Now if the fluid is heated, now we know that the density of the fluid will be decreased. If the density decreases, means it becomes light. It becomes lightweight. So if it is lightweight, means it will go up. So that's why you see the hot fluid will start to go up. So and then it reaches to the cold region. So in cold region, the fluid temperature again it becomes less. If fluid temperature is less, then the density will become heavy, or density will be increased. If density is increased, means it is heavy. It becomes heavy. So it becomes heavy means again it will start to go down. So again it will start to go down and it will come to the hot region. Again it will be heated. Its density will be decreased. Again it will go up. So like that the current flow occurs. So this current flow is called as convective flow. So this is the convective flow, and you see the current is called as convectional current. Okay, so this is the convective flow of heat transfer from hot region to cold region. So you see in this convection current mode, if the current moves due to density difference. So you have seen the hot fluid and cold fluid. In this case the current was flown because of the density difference from here to there. Because of high density to low density, current was moved. So that's why this is called as free convection. But if the current is moved due to some external force such as fan, blower or pump, then it is called as forced convection. Okay. Now in convection, you remember the formula of convection, Newton's law of cooling. The formula is Q equals to H into A into Ts minus Tf. So what is this Ts? Ts is called as surface temperature and Tf is called as fluid temperature, means the difference in temperature of the body. What is this H? H is called as convective heat transfer coefficient, or in watt per meter square Kelvin. Next, what is surface area? A is called as surface area, and what is this? Q is called as heat transfer flow rate, or in watt. Next, we see in radiation. So in radiation, you see that heat transfer occurs without any medium. So now in this case, we don't require any medium and the heat transfer occurs. One perfect example is the sun radiates heat to the earth. So earth gets heated because of the sun radiation. So this is the radiation mode of heat transfer. You see here, heat exchange between two body or medium which are separated and are not in contact with each other. It is called as radiation. It does not require any medium and most effective in vacuum. Energy received on earth from sun, this is a mode of radiation heat transfer. Next, you see in the radiation mode of heat transfer, we have sun and we have earth. So from sun to earth, you see the electromagnetic waves. Electromagnetic waves are coming from sun to earth. So energy in form of electromagnetic radiation, it comes and earth gets heated. So this is the radiation heat transfer. And electromagnetic waves travel through medium between two bodies with speed that is related to speed of light in vacuum. And the speed of light in vacuum, we know how much it is, 3 into 10 power 8 meter per second, and energy emitted by body in form of electromagnetic waves. Next, you see radiation. Electromagnetic waves comes in contact with body. So there may be 4 possible chance. It may be partly absorbed, it may be partly reflected, it may be partly transmitted, or it may be partly reflected. So this is the 4 chances that can occur if radiation occurs to any body: partly absorbed, partly refracted, partly transmitted, and partly reflected. Now we'll find out the black body. So what is black body? Black body, this is the body which absorbs all energy. That is called as black body. Now in radiation we have seen there are 4 chances: partly absorbed, partly reflected, partly refracted, and partly transmitted. So if out of this all, or instead of these 4 chance, the black body all radiation will be absorbed. So this is the property of black body. So you see, maximum radiation is emitted by black body by an ideal emitter at given temperature. Means whatever the amount of energy absorbed by the black body, same amount of energy will be emitted by the black body. So there will be no chance of refraction or reflection or transmission. The energy emitted by black body will be energy absorbed by the black body. So emissivity and absorptivity of black body is 1. So we can write the energy emitted by black body is much more than energy emitted by non-black body. Now in radiation we also know another one formula, Stephen-Boltzmann law. So in Stephen-Boltzmann law, emissive power of black body is how much? EB equals to sigma epsilon A T power 4. So this epsilon is called as emissivity and sigma is called as Stephen-Boltzmann constant. So sigma into A T power 4. Why? Because the emissivity for black body is 1. So I can replace the emissive power of black body is sigma into A into T power 4. What is sigma? Stephen-Boltzmann constant. The value of Stephen-Boltzmann constant 5.676 into 10 power minus 8 watt per meter square Kelvin power 4. What is epsilon? Epsilon is called as emissivity. This is the ratio between emissive power of non-black body by emissive power of black body. What is A? A is called as surface area, and what is T? T is the absolute temperature in Kelvin. Now we will discuss the emissive power of non-black body. So here the formula is E equals to sigma into epsilon into A into T power 4. So here sigma is Stephen Boltzmann constant 5.676 into 10 power minus 8 watt per meter square Kelvin power 4. Epsilon is the emissivity. So what is this emissivity? Emissivity is the ratio between emissive power of non-black body to emissive power of black body. What is emissivity? Emissivity is a function of surface characteristics of body or temperature of body. What is A? A is the surface area. What is T? T is the absolute temperature in Kelvin. Now we see the exchange of heat between two bodies if the two bodies are maintained at two different temperatures. Means there is a difference in temperature between two bodies. In that case, the formula of radiation is Q12 equals to sigma into A1, means the A1 body emits energy and A2 body absorb energy. So A1 the area we consider. So sigma into A1 within bracket T1 power 4 minus T2 power 4. So sigma is called as Stephen Boltzmann constant. The value is 5.676 into 10 power minus 8 watt per meter square Kelvin power 4. A1 is the area of the first body which emits energy, and T1 is the absolute temperature in Kelvin, and T2 is the absolute temperature of the second body in Kelvin. So here you have the first body and second body. The first body emits energy and the second body absorbs energy. So before I finish this today's class, I'd like to revise the topics which we discussed already. So in the previous classes we discussed about heat. So heat is the energy, form of energy which transfer or which moves from one direction to another direction, depend on temperature difference, high to low temperature. Then we discussed about temperature. So temperature is an intensive property of the body or thermal state of the system which defines that the heat moves from which direction to which direction. So the units of temperature are Kelvin, Celsius, Fahrenheit, and the units of energies are joules or calorie. And you remember the relation between Celsius and Fahrenheit, C by 5 equals to F minus 32 by 9, and the relation between Celsius and Kelvin is Kelvin equals to 273 plus Celsius. Then we discussed about different modes of heat transfer. So according to the modes, medium of the body present between two bodies, so there is solid medium if present, then the mode of heat transfer is conduction. If the mode of and in this conduction mode of heat transfer, the solid molecules or the molecules of the solid bodies are closely packed. So if there is temperature disturbance present, then the molecules of the solid body will start to vibrate, and then the next molecule also will start to vibrate, adjacent molecule, because of the vibration of the previous molecules, and they collect the energy from one place and supply to the another place. So this is the mode of heat transfer which is called as conduction mode. And the formula we remember Fourier's law of heat conduction, Q equals to minus Ka dt dx. What is K? K is thermal conductivity. What is A? Cross-sectional area. What is dt by dx? Temperature gradient. Next, in convection we have seen if the heat flows with the medium of liquid or gas, then this is called as convection mode of heat transfer. In convection mode of heat transfer, the molecules of the liquid or the molecules of the gas are not closely packed. So that's why in convection mode of heat transfer it occurs with very high, it takes very long time to move the heat from one place to another place. And in this case we have the formula Q equals to H into A into Ts minus Tf. What is H? Convective heat transfer coefficient. What is A? Surface area. What is Ts? surface temperature. What is TF? Fluid temperature. And we can classify the convection into free convection and forced convection. What is free convection? If the convection occurs due to density difference of the body, then it is called as free convection. If the convection occurs due to external force such as fan, blowers or pump, then this is called as forced convection. And in radiation we have seen that there is no requirement of any medium. So without any medium, if the heat transfer occurs, then it is called as radiation heat transfer. In radiation heat transfer, we have seen the formula of Stephen-Boltzmann law. So of non-black body, the power is sigma A T power 4. Sigma is Stephen-Boltzmann constant and A is the surface area, T is the absolute temperature in Kelvin. And the value of Stephen-Boltzmann constant is 5.676 into 10 power minus 8 watt per meter square Kelvin power 4. Next, we have seen the energy of non-black body, sigma A epsilon T power 4, where this epsilon is emissivity. Emissivity is emissive power of non-black body divided by emissive power of black body. So in black body we have seen the emissivity or absorptivity of the black body is 1. Why? Because whatever the radiation occurs into black body, all energy will be emitted or all energy will be absorbed by the black body. There is no chance of any refraction, there is no chance of any reflection. Okay. And last we have seen in radiation the difference, if there is two bodies are there, different body in different sigma A1 into epsilon into T1 power 4 minus T2 power 4. So these all we discussed in our today's class. Okay, thank you.